let's move on. So we have three leading module manufacturers presenting today, and we're happy to have with us now Astronergy, also one of the really companies that have been pushing ahead with TOPCon early on. And so it's great to have Sibin Yang talking, who is a product solution manager, and he will talk about accelerating the process of solar through N-type innovation. Sibin, the floor is yours.
Yes. Okay, let me share my screen very quick. Can it be seen?
Yes. Yes, you just have to change to presentation mode. Perfect.
Yeah. Hello, guys. I'm glad to be here and on behalf of our company to introduce our TOPCon modules. Today's topic is accelerating the solar progress through N-type innovations. Just to show that we are a firm believer in TOPCon technology. So as you guys see, we've already known the name of Qin and Astronergy. So let's quickly go through this. We were founded in 2006, and we've experienced the era of PERC. And now, by the end of this year, we've already made it's almost like a 100% proportion of TOPCon technology. And because we have the strong backup from the Qins, so Astronergy has already involved in many fields in industry. We have a full supply chain, and that's our advantage. Secondly, I'll not go through this too much because we've had Alex, who brought us very great, deep industry insight of how technology is progressing, and we've had two friends from TOPCon manufacturers to have introduction of how different technologies distributed from a few years ago and in the future. So you should be familiar with the graphs. On this point, we made the comparison of the four mainstream, or possibly the mainstream in the future, the technology as these four. So the first one is our primary technology trend is TOPCon, and we've known that HJT and the BC modules have already become the hits and the popular modules, and that comes into discussion in recent years. So we will not go in detail about how their pros and cons, but we just simplified into some dot points. So for HJT, we can see from the data sheets, the paperwork is very nice, and we can barely find the disadvantages of that modules. If those are real, and we can have true auto tests and some real time proof to say that the reliability and performance of HJT is reliable, it may become a strong opponent to us. So it's promising and green. And for BC modules, due to very new structural design, it can be combined with many other technologies, including PERC and TOPCon. So by the change of the design, it is aesthetic and is sometimes suitable for rooftop applications. For perovskite, we would expect that to turn up in the market to show its form probably in longer future. But for now, we will still say that TOPCon is dominating the market. It is most cost effective and for mass production. And as Alex mentioned, that the cost for different technologies is varying because due to the production and capacity for current markets, we would expect HJT and BC modules to have some cost reduction in the future as long as the capacity is increasing. And also we have to consider the demand for the market, but on the basis of how much TOPCon is still dominating the market, we will still see how much potential is there for those two technology to achieve. So we have a series of data from InfoLink to show how TOPCon is going to grow until 2028, by the end of 2028. So we can see that the large proportion that's in green, that is almost the tier one TOPCon manufacturers, they are still making up the numbers going up there. and we can still have some small proportion of HJT and DC modules, but we cannot see too many manufacturers following the steps except the Longines and ICO. And in the proportion of Risen and Hansen, it's expecting to be a quarter of a TOPCon by that year. So by then we will expect this March TOPCon modules to be consumed by both domestic market in China and overseas markets all over the world. So by providing those informations, we'll say that we've already successfully shifted our capacity. Previously, we include PERC, but nowadays we include almost 100%. It's 98% of the TOPCon in our capacity, and so our production capacity will increase to 59 gigawatts by the end of this year, and we also have the manufacturing bases planned and on construction or in operation already worldwide, including Turkey, America, and Saudi Arabia. So the third is kind of the feature for our company. The TOPCon series 4.0 is representing perhaps the current the most advanced current of the TOPCon technology. And we've introduced LIF, the leaf technology. We've introduced metal paste composition optimization. That is kind of the key factor that we can do to reduce the cost, and that is also significant for the overall cost reduction for TOPCon in the industry. We've attached the light redirection film at the back of the modules. Some of you may be familiar with this new sheet. So that is a small reflective microstructure layer that is made particularly 120-degree angle to reflect the light, so that it can be observed by the front line second time, because it can reflect the lights in a more regular way instead of like previously with a coating network diffuse reflection, and that's the way how we improve our power. And to increase our reliability, we've made good designs with our double glass layer to prevent water vapor from coming in, and that is more corrosion proof for modules in a very bad environmental situation, like in desert or in on the sea. So as Leo just mentioned, that for the top tier manufacturers, there's a tendency that we've agreed that the rectangular wafer will become mainstream for most of the products. So we've experienced 182 square and 210 square, but now due to the consideration of shipments and the system design, which I'll talk in the next chapter, we will say that this wafer size will be it's more like a common sense for most manufacturers to apply to their modules. So it will not only just have the system advantages compared with the previous ones, it will also give convenience for installation, etc. This is the iteration of our product from PERC, and now to the N8. So we've already catch the urgent needs for most of the markets. They want high power modules. So we will have N8, which reaches 700 plus volts. We also include N7, which used to be our primary modules in different scenarios. And we had a overlook for the primary modules that we've been providing. We will say that ASTRO N8 and N7 will be more useful in utility scales, and for residential and commercial industrial rooftop projects will apply ASTRO N7S, so all black modules. And the advantages for N8 is mainly due to its high power, because we've heard from a lot of clients they also want a higher power to reduce their cost. So the design in utility projects, we use 66 cell design. It's kind of the king of utility. It gives you the max string power and hence reduce the box cost. And there's lower possibility of hotspots than 72 cells and 78 cells. And it's also popular, known from the perk. The advantage brought by the high power will be revealed in utility scale in particularly. And also, if the mounting type is fixed rect, the advantage will be obvious. So it is ideal for ground mounting projects. But for N7, due to the size, because this module is narrower, so there's a trend in tracker manufacturers. Now they can make longer trackers. So would expect N7 modules can be connected up to 4 strings for trackers and system design, so that you will have a higher power per tracker than that of N8 modules. So we'll have a case study where we make an example. So this is the previous the N5 the power we assume is 590. So if one tracker is connected with 4 strings, because the width is 1134 millimeters, and you will be having 26 modules per string. So with that being said, the calculation will yield if you the length of the tracker is 123. It used to be a limitation for some tracker manufacturers, but nowadays they can make it longer. So we are thinking about if we can replace N5 with N7 with a higher power, with a longer tracker, we can have definitely a larger power output for a single tracker. So that's the way we reduce the system cost. But for N8, due to the length, due to the width of this module is 1303 millimeters, so it will not be able to connect that many up to 4 strings. So it may be 3 strings. So in that case, you will not be able to reach that much power output as what N7 does. So that is kind of a limitation when the tracker systems comes in, and we still provides N7 modules. However, if the mounting the mounting method is changed to a fixed tilt rect cost, so you have the homogeneous alignments for all the modules. So in that case, the high power advantage for N8 is revealed. The rect power is increased by 29.6%. So that is very large. And once you have that kind of the values from the trackers, from the racks, and you will have a great reduction in the box cost. So we've chosen a site in Spain, compared with a fixed tilted installation and a tracker bracket installation. So we still compare these 3 modules. As we can see, if this fixed tilted, the N8 modules can have a general box cost down to up to 1.08%, which is the lowest among the 3. But when it shifts to tracker installation, we will see that N7 still will take the lead. Not much, but there's still a lead. So in conclusion, N8 product has lower box cost than N5 products, from 2% up to 4.5%, depending on locations and installation methods. And the box cost of ASTRO N8 is slightly lower than that of N7 with fixed bracket installation. The box cost of N7 is slightly lower than that of N8 with the tracker installation. For this part, we have also considered different scenarios for modules. The most representative scenario we will see is the offshore PV design, because nowadays we've been seeing so many projects. They are moving to the seas or ocean due to the shortage of land. But the projects on offshore will have very strict requirements for the reliability of the modules. So we've considered to combine different materials in N5, N7, and N8 just to respond to that kind of projects. So we apply double glass, that is zero transmittance, UV resistance, aging resistance, strong mechanical strength. We have our customized frame, particularly for offshore PV design, and we also change our laminated film for a better encapsulation function operating, and our junction box and connector is dual sealing ring. Uses dual sealing ring and pull resistance junction box and connector design. So by the inside the connector, we will have two grips, and when you try to spin them, they will have a very firm grip. They will have a very firm grip, so that to increase the mechanical performance. And another trend we see is that in the future we expect that perhaps in some particular regions and areas they may have a high voltage system that is higher than 1,500 up to 2,000 volts. So the change may be due to still the consideration of cost reduction. If you have a very high voltage system, you can connect more modules and compare with 1,500. And once you are evenly, the cost is evenly distributed onto every single modules, the overall cost will be apparent. So we have an estimation if we use N7 modules and connecting to a 2,000 volts system, we have a length save by 3.6%. The bar save will be approximately 0.29 cents in US dollars per volts, and the power yield increase will be up to 1%. There's a particular dimension change here because we make the regular modules slightly larger just to try to reduce the effects of PID under high system voltage, because we have 2,000 volt systems, the edge to the distance from the edge to the cells, if you make that longer, the PID effect will not be that obvious. So that's kind of the all the contents. These are the awards to prove that we have the certificate and qualification for our products. For the 2,000 volts modules, we've already got the qualification. But for the offshore PV modules, we are still looking after the reliability proof for different combination of the materials. So that should be at the end of it. Does anyone have any questions?
Hi, Sibin. Thanks.
Yes.
Very nice. I think loads of information, plenty of questions. I think we have a few minutes still. Can you just you shared actually in one slide also where you assessed the different technologies that are out there. So what's Astronergy's R&D roadmap in terms of technology? You simply compared them, but now you're fully TOPCon. You said you're basically 100% this year. So what's next? Or is it time?
For our roadmap, we are investigating the reliability of BC, perhaps, and a small proportion of HJT. Because from my perspective, the reliability of HJT is still vague for us, and we're still trying to figure out what possibly can be done if we can have a reliable HJT modules. Because as a TOPCon manufacturers, every time we try to compare our modules with HJT, honestly, we lose confidence if we see the data sheets. You have those better coefficients, temperature coefficients, and the linear degradation is all fine. But there was a report from 1 or 2 years ago, and we're not confident about what the report suggested because the degradation is not as ideal as HJT should be. But we still see the potential of BC modules. And because BC module is just a change of the design, we can still cooperate our TOPCon technology with the BC design. So our roadmap in the next 3 to 5 years will be most likely TOPCon and get up to 5.0 or more advanced, and with BC modules and small amounts of HJT.
Okay. You also mentioned some offshore PV designs, which is a little bit obviously more costly because it's adapted to certain needs. And I think there was also a tendency that we've been seeing recently in the market that some companies then adapted their products a little bit to the needs of customers. So in these times where basically you have to pay almost for every module you're producing, is that truly possible, or is this a market which is still attractive? Like Alex said, okay, if you're selling to the US, of course, then there's a margin to be made. In others, Europe, probably not.
Okay. Actually, fortunately, I have a discussion conference with a domestic design institute in China. They've already tried to build up an offshore PV design, and by then there were so many manufacturers going there that provide their design and plans. So, but what you said is right, because every project offshore is costly, and so you have to consider the reliability of the module. So the materials that you use, encapsulating film, and the frame and the glasses, you have to put it up to the next level. You have to have a more strict standard or what, and to cooperate with the strength of the modules, particularly for mechanical performance, and you will face the risk of corrosive seawater and the sea wind. So by all those comes together when it goes to offshore PV design, we are still looking to if there's any design standards that we can follow for most of the customers. They can have a clear idea like what particularly modules they can choose. So that's why we have alternatives of N5, N7, and 8, just to give the clients the options if they are facing different kind of situations, so our modules can be more adaptive.
Okay. Maybe one question still from my side, and then there are some in the chat which you might take there. You're now, yeah, as you said, basically at 100% TOPCon, and you're also producing modules in the US. As I understand, there's also some IP issues with TOPCon in the US. How are you dealing with that?
I think for our American selling teams, we are keeping track in the trace and the carbon emission and the IP issues in America. That is a big headache because our American manufacturing basis is still going on operation. Because before that, our shipments it's really a headache for us. I think it's getting better if the basis is settled down, so that we can have the shipments like directly from America instead of from our other manufacturing bases such as Thailand or Turkey, etc.
Okay, thanks. There are some questions regarding 2000 watt system voltage in the chat. Maybe you can address it there. Thanks, Sibin.
Yes.
That was very insightful.
Yeah, thank you.
Okay, cool.